Our next speaker will be Mr. T.S. Rao, COO of Madras Engineering Foundry Division, who will be sharing his valuable insights. We call upon Mr. K. Hem Prasad, Council Member Chennai Chapter, to introduce Mr. T.S. Rao to our audience.
So, good afternoon to one and all present here. It's my pleasure to introduce today's speaker, Mr. T.S. Rao. Basically, is a diploma in draftsmanship and design, masters in public personal management, and MBA in TQM. His certification includes certified lead auditor for almost all certificates including PED, Dale Carnegie trained leader, Lean Six Sigma black belt, certified global mentor, AFS Lost Firm Council member. His experiences 36 years of Foundry experience in all processes including sand, centrifugal, GDC, lost wax, lost foam, and replicates with all materials including iron, steel, and copper alloys with hands-on experience in new product development. He traveled over 17 countries for business development. He developed over 2,000 products from APQP to PPAP. His experience includes 20 years in Hinduja Foundries Hyderabad, 1 year in Hindustan Motor Kolkata, 2 years in Dakshin Foundry Bangalore, 1 year in PT Casting Hyderabad, 12 years in Armstrong Fluid Technology Bangalore. Recently, he joined Madras Engineering as a COO. Thanks you for. Sorry, sir.
I think it's a lot of confusion. So, sorry, we are calling you back for another presentation. It's a painful process, but I'll try to make it more interesting. So, we had a very good sessions in the morning. Let us go through the presentation mainly on the transforming workforce towards meeting the new generation quality standards. So it is very similar to the previous presentations, but let us make it more exciting. So this is the topic of the day. The introduction to the Madras Engineering we started in the year 1966, and we are the second largest brake system manufacturers in the world. And we have 5 manufacturing plants all in Chennai and 1 group company in UK. So our parts goes all over the world. Coming to the Foundry division, these are the unique features of the Foundry division. We have 2 molding lines. They work independently and also together. And we are operating with a full capacity. These are the unique features of the Foundry. We produce only ductile iron, and we have 2 separate molding lines, DISA C3 lines. They work simultaneously and independently. And we have safe liquid metal handling by 6-axis robo, and also we have the Precipo. We have hydraulic trimming for avoiding fettling, and we have lean single piece pour, like within 6 hours of the pouring, the parts get shipped out to the customers. We produce 1 million parts, 10 million parts every month. And we have 2 large rain harvesting plants which cater 33% of the plant water requirements. And 86% of the energy is from the renewable. So this is a product, the mix of the business. And the objectives of the presentation is to throw light on the next generation quality standards and support Foundry fraternity by knowledge sharing, support Indian Foundry industry to compete with the rest of the world by better understanding of the modern quality standards, and improve customer satisfaction, enhance collaboration with the customers for the mutual benefits, quality improvement, cost reduction, and as you know, the transformed workforce is the most precious resource of any organization. So let us go through the abbreviations. Like you know, the abbreviation of the topic looks complex. I wanted to make it into 4 categories so that everyone can understand better. So what is the transforming? Transforming is a dynamic change that is happening on every day. So it is visible to everyone. That is a transformation. Some of the examples of the transformation is like the lifestyle. There is a transformation. Attitude of the people. The artificial intelligence our friend spoke. That is a transformation. The speed. The transformation in the speed. The infrastructure. The product design. The deliveries. The expectations. The imaginations and the comfort. This is a transformation. the what we see in physical, what we see, which can be noticed by everyone, is a transformation. And what is the workforce? We know the workforce. So we have a couple of examples of the workforce, like the industrial workforce, the military services, the medical healthcare, fire brigade, security, housekeeping, police, construction, task force, crew. These are all the workforce. Then what are the quality standards? We know the quality standards are the documents which are used in day-to-day life. These can be in the form of the drawings, these can be in the form of the material of construction, these are in the form of acceptable criteria, these are in the form of fit, form and functional requirements of the product. It can be a document, or it can be a standard like ISO, Environmental Management System, or OSAS or IATF. It can be British Cashier and Dispatch Association documentation, ASTM or ASME. These are all called documentation as we deal in day-to-day life. These are documentation. And let us also go through the history, how the quality standards are evaluated over the periods. If you see the trend, like the actual production started during the 13th century. It is all started with the craftsmanship, or we also called artisans. From then it started. In the 19th century, the industrial revolution started, then Taylor system, quality process and statistical control systems are in place. During the World War II, the sampling and standards started getting implemented. In 1946, the ASQ started implementing the standards. Then over that you can see now we are in Industry 4.0 and mainly on artificial intelligence. So historically the quality control and inspection in the minds of the people, because there was no documents available at that point of time. And the knowledge which is in the mind of artisans are transferred over the generation through the word of mouth or by the demonstration while working. So the knowledge, it is also called the tribal knowledge, is got deteriorated over the period because of the reasons. There is no documentary evidence, it is not documented, and like it kept as a secret due to copyright. They thought like, no, if I teach to others, I lose the importance, and they are likely to copy. That is one of the reasons that we are losing the talent. And fear of losing the importance, as we discussed, the successors are not keen, like farmer's son is not keen to continue as a farmer. Similarly, the artisan's son is not willing to continue as an artisan. So that is one of the reasons that we lost the traditional knowledge. And the invasions, the invaders who invaded India, they killed the knowledge, the tribal knowledge what we had in the minds. And importance, the most important is the globalization. Because of the globalization, we lost the importance, and the traditional knowledge what we had started fading away. So the current, if you see the current quality standards, when they start implementing, like the inspection started in the year 1300, then TQM started in the year 1920. The total quality management, the Taylor system implemented in the year 1924, the design of experiments started in the year 1935, the mill standards started in US, these are military standards in 1945, the ISO is originated from the mill standard. Then ASQ, American Standards for Quality, they started in the year 1946. Then 7QC tools introduced in the year 1950. Then quality function deployment started in the year 1960. New 7QC tools introduced in the year 1976. APQP, PPAP, MSA, SPC introduced in the year 1980. Then Six Sigma and DMAIC, the define, measure, analyze, improve and control started in the year 1986. Then Kaizens introduced in the year 1986. ISO first launched in the year 1987. And Taguchi method introduced in the year 1990. The quality management system is launched in the year 1991. If you see, none of these are launched after 1991. That is the history of the quality standards. The deficiencies are, I say, shortfalls in the current quality systems. They are all built to the generations which are living today, and they are not meeting the future generations because of the Industry 4.0 revolution. The customer expectations are exceeding, and they are expecting the digitization in the requirements. And if you see, the current standards are mostly human dependent. They are not the artificial intelligent or 4.0 compliant, less digitized, delay in communication with the customer. Like if you see, today we inspect the parts and then we transfer into the Excel, then we scan it and send to the customer. It takes days. The customer receives the inspection reports. Errors in reporting, it is a human dominant process. There are likely to be errors in reporting. And limited to quality function. Always people think the only quality department is responsible for the quality. That is another deficiency in the current quality standards. And reactive than proactive. We only react whenever there is a complaint, we jump into the action. Otherwise, we are not proactive in current quality standards. And it is a COPQ based. It is a cost of poor quality based, not total cost of quality base. So that's a big difference in the current quality standards. And leadership focus is missing. Always leadership focus on the business development, getting more and more business and bottom line, not on the quality system. These are the shortfalls in the current quality standards. And then before we go to the next topic, let us recollect the quality gurus who contributed the quality so far. So start with Mr. Deming, born in USA. I'll not read much because we are all familiar with the Deming. So the contributions he made to the industry, including PDCA, Deming cycle, that is also called Deming cycle. And Mr. Juran, he also born in USA in 1904. So these are the Juran's contribution to the quality. The Pareto, the cost of poor quality, then quality council. Interestingly, Juran and Deming, they are from US. So when they started teaching in US, no one listened to them. Then after the Second World War, they went to Japan. Japanese listened to them. They accepted what they say is correct. Then they implemented, they shown the results. Then US recognized this. Then they called them back. Then they started implementing the techniques, and US also got benefited out of it. So coming to Shinjo, he is born in 1909. So he is the man who introduced the Toyota production system, just in time, single minute exchange of dies, poke yoke, error defects. So Ishikawa, more popular in India. So Ishikawa diagram is known to every, the Foundry fraternity in India. User-friendly quality system, fishbone diagram is also later called Ishikawa diagram, quality circles, internal customer concept. So 7 QC tools, cause and effect diagram, statistical. Next, Figuerbom, he born in USA. He is a man who is behind the total quality management systems organization. He thought that single most important C is quality is for the organization success, hidden plant, extra workforce, accountability to quality. Quality is, he said, quality is everyone's job, not only the quality function job. Quality leadership, striving for quality, everyone to be trained on the quality, organizational commitment. Coming to the Taguchi, Taguchi is also very popular in India. He is the man who is behind Taguchi's method. So prototyping, quality function deployment, so loss function, measuring financial loss. He also said that the loss is not to the organization, it is a national loss. 3 strategies for the quality control design, system design, parameter design, and the tolerance design. Mr. Crosby, definition of quality, he is the first person who defined the quality is a fit, form and function, conformance to the requirements, prevention, how prevention helps the quality, zero defect. So price for non-conformance, price for conformance, and Garvin's contribution is the 8 dimensions of the quality: performance, features, reliability, conformance, durability, severity, and aesthetics, and preserved quality. So going to the next subject, what are the next generation quality standards? So they are certainly different from the current quality standards. We have seen current quality standards, last update was in there 1991. What are going to be the new generation quality standards? How is going to help us and is going to help the new generation, the workforce in the organization? Why do we need it? The current workforce is a modern with respect to the education system. They got educated from the better universities, better education system than us. And because of the globalization, the dynamic and increased customer expectations on day by day, the competition is mounting up, the AI and automation what we discuss, and least communication gap. Customer would like to see what we are doing today in the shop floor, not after 1 week. So the expensive liability cost, the liability costs are increasing every day. It's not easy to face the liability costs. The availability of advanced measuring and monitoring equipments. The time is money. No one is having time to spend on the quality. Quality has emerged as a business strategy. Now it is a business strategy. If you improve the quality, you get the business. That is a business strategy today. So if you see, this is very interesting, the pyramid. The preventive cost, if you can prevent the defect in the shop floor, the cost is say one is 1 rupee if you can prevent it. If you can correct it, if you detect in the final inspection or detect before shipment, the cost of repair is going to be 10. If it is detected in the customer end or the field failure, the cost is going to be 100 times. So 1 rupee become 100 rupees. So imagine how important to prevent the defect at the source. Impact of the hierarchy. If you see the hierarchy, it is very interesting. The most of the defects are produced either by the shop workforce at the developing level or the shop supervisors. More than 50% of the defects are being produced by the people who are in the shop floor. Unfortunately, they are not focused, they are less cared in any industry, and unfortunately most of the defects are being produced by the people at the shop floor. Next gen quality standards, and what are the next gen quality standards and how it helps, let us understand. So these are going to be digitized and also they are like technology driven, and online communication with the customer can see live so what we are doing today in our supplier base, and nil errors in reporting, total team collaboration and involvement, top man to gate man, everyone will be focusing on the quality function in the organizations, and it is preventive action rather than the detective action, and it is going to be total cost of quality to the percentage of sales, and it is a leadership driven, and it is going to be industry 4.0 compliant, is going to be autonomous inspection, and relieving customer from re-inspection. This is very, very important. Why customer should inspect when you are inspecting and supplying, and reducing inspection cost, and self-certification. Suppliers are expected to be self-certifying the products and ship to the customers. So this is one of the example of inspection of a component. In a conventional way, normally we take a casting, we take a 2D drawing, and we keep making ballooning, and then we'll be converting into an Excel or a piece of paper. We'll be inspecting each feature, and then one person will be inspecting either by height gauge or the vernier, and one will be reading and making notes on a piece of paper. Then they go back to the computer, they type it. While doing this, while transferring person to person, they are likely to do a lot of mistakes, and then they take a print, signatures, scan and send to the customer, or send Excel by email. Imagine how much errors that would happen during the transition, and not less than a week. Imagine how fast it can be done by a simple 3D scanning where the customer can see live. So similarly, the communication to the customer, at the moment you click, customer can see a report on the other side. That is going to happen. See how the errors can be detected in the new generation quality standards. When the millions of bottles are manufactured, how the artificial intelligence can detect a bad product and then separate it from the mass production. It can get automatically detected. See how speed, how precision, and the whole how the team can work together in an organization on timely manner. Imagine how fast, in less than 10 seconds, the 4 wheels get replaced by a team. It's a real live video, 8 to 10 seconds. So that is the speed we are expecting, that is the precision we are expecting, that is the team involvement we are expecting in the new generation quality standards. And preventive action. How do you prevent the bad parts goes to the customer? So POCA is one of the preventive action. FMEA is another preventive action. Documentation of all expectations. Thorough understanding of the product expectations before product development. 100% employees are trained on the respective the customer requirements. Continuous assessment and retraining. Next in command. Normally it happens when a part to be inspected, say the trained inspector is on leave today, we'll inspect later or whenever he is back to work. So that is happening today. So it's very important next in command. When A is missing, B should come and take over and he should start inspecting the parts, and there should be a succession plan. Always the person next to him should be able to catch up. And multi-skilling is very important factor. Every employee own their function and autonomous working, they have to work independently. And every non-conform is thoroughly dealt with 8 disciplined principles. And unplanned audit. Audit should not be planned, it has to be unplanned. Surprise audit should be happening, that will prevent the loss. So it's an example of leadership. How leaders are expected to work in any organization. When a group of people working together to a common goal, here the ants, they are working together. They are collecting the food and storing for the rainy day. Suddenly there is an obstacle on their way, it stopped. They got demotivated, they got scared, they thought the demon fallen on them. They doesn't know what to do. At that point of time, the leader came in to support the team. They ensure that the continuity in supplies. So he is trying to help them how to deal with the obstacle. He helped them how to deal with that. What is the other way around? So he is trying to motivate, don't get scared, look at me, follow, then take another path, it lead to success. So that is how the leaders are expected to work. The leaders are expected to be at the back and come front whenever there is a requirement, support the team. Oh, sorry. This is on like we have surprised like what is industry 4.0. I'll take you through what is industry 1.0, what is industry 2.0, and what is industry 3.0 and where we are in today. We started with the manual, the working, then gone to the semi-automation, then gone to the robotics and PLC. Up to here we are all comfortable. Now the industry 4.0, it is mainly cloud-based. We had a detailed presentation in the past. So it is a cloud-based, everything will be automated. So this is an autonomous inspection, how the robots work independently based on the program. So the customer sits miles away from the site where he is expected to inspect the site. So he engages a robot for doing his work, and the site engineer spots a location saying that this is a spot the robot is expected to inspect. So based on the instruction, the robot starts going to the every location and inspect, take a pictures and send command to his boss sitting miles away. So he get a real-time data. The robot goes everywhere, wherever the spot is marked in the inspection site. It goes up, down, travels everywhere. Wherever there is a mark, the robot goes and take the pictures and send to his boss. What is the pressure at the particular location? Imagine how it is working independently. It is called autonomous inspection. So we are also expected to work in the same way. All done. So it's the time to take rest. See, 11 measurements in 14 minutes. So that is the speed the customers are expecting today. So Customer should be free from inspection. Why customer should be inspecting our products? Customer is paying for the product. Why he should inspect again? So just in time, customer doesn't have time to inspect. He expects only 1 hour before the assembly, the parts are expected to reach the customer location. Geographical and cultural reasons. Normally people in the West, they don't think that we'll supply bad part. They don't have time to inspect the parts. It just come, it will directly go to the assembly line and get assembled. And inspection is expensive at customer location. And impact of defects deteriorated at customer location. And rework cost is going to be very expensive. As we know, the 110 and 100 rule. Line stoppage is going to be very expensive. Recall and the potential risk of mix-up in the previous batches, that is going to be a big impact on the customers. And parts in WIP, logistics at the supplier location, all is going to be non-conformance if any non-conforming part is detected. So remark on the supplier. At the moment he detects, he thinks he is a bad supplier. That affects the business of the suppliers. So this is another example of the reducing the inspection cost. These are the small fasteners, how the inspection takes in place in automated way. So all geometry, the XYZ, all direction, the part get inspected with the sensors and they get all information. Every product get inspected in no time and the bad parts thrown out of the machine. And reworkable parts are getting collected separately with an identification, is a OD oversize or OD undersize. That's a speed error-proof inspection. And let us spend 1 more minute on the artificial intelligence and how it works. So there could be an accident, there could be a damaged cloth worn by the customer, there could be a chocolate with the stones inside. So these are all the various customer experiences. So what are the causes? The causes can be many. So because it's a human dominant process, the inspector is not likely to focus, which is another side. He must be maybe soon after lunch. This guy may be old and is not that keen on inspecting the parts. These are the root causes leading to the customer dissatisfaction, and it is the customer dissatisfaction is money. So how do we prevent it? We have solution in artificial intelligence. So it can detect the bad part quickly. It gives, you can see that it gives a grind structure. Organic, inorganic, foreign particles, everything get detected. At the moment the bad part is detected, it get noticed. So how do we transfer the workforce? We have seen the examples, we have seen the traditional standards, we have seen what is the customer expectation, we have seen what are the new generation quality standards, and how do we transfer the workforce is only continuous training and education, product and process requirements, Gemba walk, visit customers, go to the customer, understand the fit, form and function, understand what is their expectations and listen to them. Gemba walk, as I said, in one of the, like more than 50% of the defects are happening because of the workforce in the shop floor. Walk along with them, listen to them, respect everybody's opinion, encourage when achieved, support when failed. This important, appreciate in public, explain in private, not scold in private, explain in private. So stand as a role model while leading the teams, as we have a couple of examples in the past slides. We should have empathy and dealing with this. So this very good example on the transformed workforce. If the workforce is transformed by the training, so how it helps an organization. It happened exactly 50 years ago in the Japan in a very expensive soap factory. This is a sequence of operation in the soap factory. The operator places soap in a solo box. I think many of us know this. It is taught in many of the training sessions. So the operator is expected to keep soap in a soap case manually and keep on the conveyor belt. The conveyor takes the soaps to the packing station. Then they get packed and go to the customers. And there was a customer complaint that one of the soap case doesn't have soap inside because this is a premium soap brand in the Japan, very expensive soap. Then management got into the action. They started analyzing the root cause. They found that low cycle time for placing soap inside the box, and it is a human dominant process. People are not likely to work same way every time. Then what is going to be corrective action? They thought, let us have a scanners, they have a automated detection lasers or a load cells that get automatically detected. They were all thinking very expensive solutions. The transformed workman, he got a brilliant idea. He introduced a pedestal fan to the conveyor belt. So whenever the empty case come, it flew away from the conveyor. So very, very simple and innovative. That is the advantage of transformed workforce. It is our responsibility to transform our workforce towards a strategical thinking like this. Okay, with this is a disclaimer, because the examples I showed is very unique, the exposure what I have in the business. So they are not likely to work in every business because of the various reasons: nature of business, customer expectation, geographical locations, cultural change, dynamic change. See, the customer what is expecting today, the expectations tomorrow certainly is going to be different. Okay, if any questions, I'll be happy to answer.
Any questions?
Looks like everybody's hungry.
Yeah, that's why I have to finish quickly in 30 minutes.
Since we announced in advance, that is also kindred. Any questions?
Any questions?
Sir, as you said in your unique feature, you told that it's only ductile iron. Is there any strategic plan behind that only ductile iron, or?
Yeah, we had, as I explained, like we were producing ductile and grey together. 90% is ductile and 10% is grey. Then we are running with out of capacity. We have about 115% of the load. Then why should have the combination? Then we decided to outsource ductile iron. We produce, grey iron, we produce only ductile iron. That helped us a lot in managing the scrap and managing the consumables as well.
So I should appreciate, like the presentation before lunch, you have made it so good with all visuals and made it very interesting. With respect to foundry industry, how far this zero defect?
It's all, as I said, is leadership driven. It has to be leadership driven. Everyone, gateman to topman, has to be involved in total quality management. Then only it will happen. As you see in one of my slides, 50 to 60% of the defects are made by the workforce in the shop floor and the line supervisor. They are to be focused. They have to be listened. They have to be respected. And every non-conformance, I'm not talking about rejection, non-conformance, whether it can be reworked or rejected later. Every non-conform has to be dealt through the 8D principles. Then we will find solution. It is an ongoing process. And I'm sure it can be zero defect. It requires some amount of focus and dedication.
Any questions?
Thank you, sir, for pitching on the importance of quality, its impacts, what would be the new generation quality standards, and how AI and automation helps in maintaining the quality standards. Now I invite Mr. M. Armugam, Council Member IEF Chennai Chapter, to felicitate Mr. T.S. Rao with the traditional Angavastaram, and Mr. Vignesh Ramanan, Vice Chairman IEF Chennai Chapter, to felicitate with the memento.